Hey YouTube! Ion traps are used to capture and sort charged particles in mass spectrometry, quantum physics, and atomic timekeeping. Sitting beside me is my model non-magnetic quadrupole mass filter, also known as a Paul trap. Electrically charged particles, whether individual ions or larger objects like dust, feel a force when subjected to an electric field. This is the same force that holds a charged balloon to a wall. Paul traps use a 4-pole electric field to confine charged particles within a defined volume. However, Earnshaw's theorem states that it is impossible to trap a particle in all three axes using static fields. To successfully trap particles, a Paul trap uses dynamic electric fields that constantly change polarity. Invented by Wolfgang Paul in the 1950s, Paul traps can be made in two basic configurations: 4 parallel bar electrodes, or 2 hemi-ellipsoid electrodes with a ring electrode between them. Both configurations work on the same principle. Opposite electrodes, in both configurations, are electrically connected, so that when power is applied, they are the same charge. A charged particle that is injected between the poles will be attracted to one set of electrodes and repelled by the other. When the polarity of the power supply changes, the attractive and repulsive forces will change polarity as well. These constantly changing forces cause the particle to feel confinement in one direction and anti-confinement in another. By adjusting the strength of the force and the rate of the change, it's possible to have the particle feel a net confining force, which traps it in a volume of space. In the 4-bar trap, there is no confinement in one direction. This allows particles to be moved from one place to another inside equipment. The ring trap can be thought of like the linear trap, but with radial symmetry, so that the hemi-ellipsoids confine in one axis and the ring electrode confines in the other two. Paul traps can be used in mass spectrometers to sort particles based on their mass-to-charge ratio. When the strength of the electric field is increased, particles will pick up more momentum based on their mass-to-charge ratio, leading some of them to eventually be ejected from the trap. Building these traps was surprisingly straightforward, and I was amazed to see them work. I hope you found them as interesting as I did, and if you'd like to see more, check out my channel. Thanks for watching.